Here I am solving two knights problem from CSES Introductory problem set. The task is to count for k equal to 1 to n the number of ways two knights can be placed on a k by k chessboard so that they do not attack each other. Input will be a integer, and we have to find all the number of ways we can place two knights on input cross input means 8 by 8 chessboard such that they do not attack each other. Here the answer is 1848. Now let us see in how many ways we can actually put two knights on a chessboard. So if you want to place a single knight on a chessboard, there will be n cross n possibility, and as one place is occupied on chessboard, for second knight we will be having n into n minus 1 possibility. These are the total number of ways we can put two knights on a chessboard. Now let us check in how many ways two knights can attack each other. Let us say first knight is placed on any corner of a chessboard, then it can attack these two positions. So as there are four corners in chessboard, all the four positions can attack two different positions. Therefore, we will subtract this 4 multiplied by 2 from our total value. Minus 4 into 2. Now, if we put our knight here just below the corner position or by the corner position, then this both the place will attack exact same number of position, which is 1, 2 and 3 position. If it is placed here, it will attack 1, 2 and 3 position. That's why there will be total 8 such positions which attack 3 different positions on chessboard. Therefore minus 8 into 3. Let us say if we place a knight here 2 blocks below the corner, then it can attack 1, 2, 3 and 4 different blocks. Now this 4 different block attacking will continue for all the line, or we can say whole column, until n minus 2. Now if we say here is our corner piece, then corner plus 1 and corner plus 2 for this position, it will attack 1, 2, 3 and 4 position. That's why there will be n minus 4 such position which can attack at 4 different position in all the 4 row. As we are having n minus 4 position in this column, it will be in this row also, this column also, and this row also. It will be multiplied by 4. Now we have covered the corner of the chessboard. Now we will move inward in the chessboard. Let us say we place our knight here, then it can attack here, here, here and here. It can attack this 4th position. As there will be 4 inward corners, therefore we will subtract this 4th position multiplied by 4 attacking position. So minus 4 into 4. Let us say we place our knight here below the corner, so it can attack 1, 2, 3, 4, 5 and 6 different positions. Now this will continue till n minus 4, means till the end of row, and we can see the same pattern if we place a knight here. That's why there will be n minus 4 such positions, which will be n minus 4, which will attack on 6 different places on all the 4 sides. That's why we'll subtract it. Now if we move inward here, this place can attack 1, 2, 3, 4, 5, 6, 7 and 8 different positions. Now this position can be manipulated with all the n minus 4 into n minus 4 board. So we will subtract this position from chessboard, which will be n minus 4 into n minus 4 into 8 positions. Now let us code this. Two knights. I will be our integer input for n in I, or we can say for n in range I. Answer will be n multiplied by n, which will be again multiplied by n into n minus 1. We will subtract first this 4 into 2, which is 8, minus 8 is a 24, minus n minus 4 into 16, this is 16 into n minus 4, minus 4 was a 16, minus n minus 4 into 24, 24 into n minus 4, minus n minus 4 square into 8, n minus 4 square into 8, and print the answer. Okay, we are getting the wrong answer. We have to divide the final answer by 2. Okay, we have to go from 1 to I plus 1. Okay, here we are, here we got our answer. The reason behind dividing this by 2 is when uh, when we put our knight on any position and it will be attacking different positions, then if we put another knight here, then it will be attacking on this position, but it is already covered in a previous position. That's why we will be having doubled answer. That's why we divide the final answer by 2. Thanks for watching the